Imagine you and 9 strangers are sitting around a table. Every time someone spends money, everyone at the table writes it down. Nobody can cheat, nobody can erase anything, and nobody's in charge. Now imagine that table has millions of people on it, spread across the entire planet, and instead of paper, they are using math so complex, it would make your high school teacher cry. That is blockchain. And once you understand it, you will never look at money or trust the same way again. To understand why blockchain exists, you first need to understand the problem it was built to solve. And that problem is trust. Every time you send money to someone, through a bank, PayPal, or any financial system, you are not actually moving anything. You are asking a trusted middleman to update a number in their private database. Your bank says you have a certain amount. The other person's bank says they have a certain amount. You both just trust that those numbers are correct. You trust the bank. You trust the institution. You trust that nobody is lying. But what if you did not want to trust anyone? What if you wanted a system where the record itself was the proof, where no single person, company, or government could alter, delete, or manipulate the history of transactions? That is exactly what a man or woman or group of people nobody actually knows, going by the name Satoshi Nakamoto, set out to build in 2008. The result was Bitcoin, and the technology underneath it was blockchain. A blockchain is exactly what it sounds like. A chain of blocks, not physical blocks, digital ones. Each block is essentially a container that holds a batch of recorded transactions. When the block is full, it gets sealed, stamped with a unique digital fingerprint called a hash, and attached permanently to the block before it. Then a new block starts, and another, forming a chain stretching all the way back to the very first block, called, with a certain poetic flair, the Genesis block. Here is where it gets interesting. That hash, the digital fingerprint, is not just a label. It is calculated based on everything inside the block. Every transaction, every number, every piece of data. Change even a single character anywhere in the block, and the hash changes completely. And because each block contains the hash of the block before it, tampering with one block breaks the fingerprint of every block that comes after it. The chain collapses, the fraud is immediately visible. It is like trying to change a word in the middle of a book, except the book automatically rewrites every page after it to reflect the change, and everyone in the world can see that the pages no longer match. Good luck with that. Now here is the part that makes blockchain genuinely revolutionary. There is no central server, no headquarters, no single computer holding the master copy of the chain. Instead, the blockchain is copied across thousands, sometimes hundreds of thousands, of computers around the world simultaneously. These computers are called nodes. Every node holds the full history of every transaction ever recorded on that blockchain. When a new transaction happens, it gets broadcast to the entire network. The nodes check it, verify it against the existing chain, and if the majority agree it is legitimate, it gets added to the next block. This process is called consensus, and it means that to successfully tamper with the blockchain, you would not just need to hack one computer. You would need to hack more than half of all the nodes on the network simultaneously, rewrite their records, and do it faster than the network keeps adding new blocks. For a large blockchain like Bitcoin, that is effectively impossible. It would require more computing power than currently exists on Earth. So nobody even tries. This is what people mean when they call blockchain decentralized. No bank, no government, no CEO with a bad day and a delete button. Just math and the collective agreement of thousands of computers that have never met each other. When you send cryptocurrency on a blockchain, here is what actually happens. You broadcast a transaction to the network, essentially saying, I want to send this amount from my address to this other address. That transaction sits in a waiting area called the mempool. the memory pool, along with thousands of other pending transactions. Meanwhile, certain nodes called miners are competing to bundle those transactions into the next block. To do so, they have to solve an extremely difficult mathematical puzzle, a process called proof of work. The first miner to solve it gets to add the next block to the chain and is rewarded with newly created cryptocurrency for their trouble. This is where new Bitcoin actually comes from, not a printing press, a math competition. Other blockchains use a different system called proof of stake, where validators are chosen based on how much cryptocurrency they hold and are willing to lock up as collateral. Less energy intensive, less dramatic, but equally secure. Ethereum, the second largest blockchain in the world, switched to proof of stake in 2022 and reduced its energy consumption by over 99% overnight, which, given that Bitcoin alone once consumed more electricity than entire countries, was probably overdue. Here is where blockchain stops being just about money and becomes something far more interesting. In 1994, a cryptographer named Nick Szabo had an idea. What if you could write a contract, a legal agreement, directly into code and have it execute automatically when certain conditions are met? No lawyers, no courts, no middlemen, just code doing exactly what it was told. He called it a smart contract. And while the idea sat dormant for years, Ethereum made it a reality in 2015. A smart contract on a blockchain is a self-executing program that lives permanently on the chain. It cannot be altered. It cannot be switched off. When condition A is met, action B happens automatically, always, without exception. This opens up possibilities that go far beyond cryptocurrency. Supply chain tracking, where every step of a product's journey from factory to shelf is recorded permanently and cannot be falsified. Voting systems that are transparent and tamper-proof. Digital ownership of assets through NFTs, which, yes, had a rather chaotic period that involved people spending enormous sums on pictures of cartoon monkeys. But the underlying idea of provable digital ownership is genuinely significant. Decentralized finance platforms that let people lend, borrow, and earn interest without ever touching a bank. Blockchain is not magic. It is not the answer to every problem. For years, the word blockchain was attached to every startup pitch, regardless of whether it made any sense. A phenomenon so absurd that it briefly became a running joke in the tech industry. Companies were adding blockchain to their names just to boost their stock prices. At least one company that sold iced tea rebranded itself as a blockchain company in 2017 and watched its shares jump 200%. Briefly, the honest truth is that blockchain is genuinely revolutionary for specific problems. Situations where you need a tamper-proof, transparent, decentralized record that nobody controls. For everything else, a regular database is faster, cheaper, and simpler. The technology is powerful. It is just not always the right tool. Blockchain is, at its core, a new way of creating trust. Not trust in a person or an institution or a government. Trust in mathematics. Trust in a system that is transparent by design, tamper-proof by structure, and controlled by nobody and everybody at the same time. Whether it reshapes finance, law, governance, and ownership the way its most enthusiastic supporters believe, or settles into a useful but quieter role in specific industries, is still being written. But the idea itself is profound. For the first time in human history, two strangers on opposite sides of the planet can exchange value, sign agreements, and verify records without trusting anyone in between. That is not nothing. That might actually be everything. Thank you so much for watching. If this made blockchain finally click for you, hit the like button and subscribe to Capsule for more big ideas explained clearly. See you in the next one.